Welcome to springlib.
Okay, so we have the following ketone, and we basically need to do retrosynthetic analysis and think of the two ways that we could generate this ketone, right? So we could break this bond or we can break this bond. Actually, I'm going to do that in a different color, right? Those are our two options, which is to say we could start here and react with methyl magnesium bromide, or we could start here and react with 1, 2, 3 butyl magnesium bromide. Right. Either one would work. So, given that, what we then need to think about is, okay, we don't have starting materials that, we don't have this acetone or acetaldehyde, right? So is there an alcohol that's similar to this? And the answer is yes. If we start with ethanol, right, then we could use PCC to get the aldehyde, for example. If we start here, do we have a butanol to work with, right? Do we have one butanol available as a starting material? And we don't, right? This isn't one of our options. We only have methanol, ethanol, 1-propanol, 2-propanol, or cyclohexanol. So we can't do this path. We're going to need to start from here, right? So basically what the synthesis is going to be is turn ethanol into acetaldehyde and then react acetaldehyde with this magnesium bromide. And butyl magnesium bromide. And that's basically it. So step one is turn ethanol into acetaldehyde, right? So starting material, I guess, is ethanol. Okay. Which is number 2. Okay. First step is pyridinium chlorochromate. That's N2. Okay. And then the next step would be reacting these together. So if we react this aldehyde with butyl magnesium bromide, they will form the following, right? And then the final step would be we need to turn this from an alkoxide into a ketone, right? And we could do that with chromic acid, right? So CrO3 will protonate. Will both protonate and oxidize our final to our final product, right? So what we're saying is ethanol, PCC gives us acetaldehyde, okay, CH MgBr. 1, 2, 3. Oops, went too far. And there we are. Altogether, the letters for that are 2, N, K, and then G.